Hello, welcome back to Eduverse. For thousands of years, humans have looked up at the night sky and seen a static picture. We thought we were looking at the universe as it is. But we weren't. We were looking at a ghost. See, light takes time to travel. It's fast, unbelievably fast, but it's not instantaneous. When you look at the moon, you see it as it was 1.3 seconds ago. The sun, 8 minutes ago. We are literally looking into the past. When we point telescopes at a galaxy 10 billion light-years away, we see it as it existed 10 billion years ago. We are exploring time. This fact has given rise to one of the most transformative fields in modern science, galactic archaeology. Just as archaeologists here on Earth dig through layers of dirt, cosmic archaeologists dig through layers of light, hunting for the fossils of the early universe. We are finally reconstructing the universe's origin story, using everything from ancient starlight to ripples in space-time itself. Buckle up, we're going time traveling. How do you dig when your shovel is a telescope? The goal isn't just to make a map, it's to reconstruct history. For a long time, we were limited, but the last 2 decades have been a revolution. We've moved from looking to analyzing. The MVP of this new era, the James Webb Space Telescope, or JWST, it's the ultimate time machine. As the universe expands, light from the most distant objects gets stretched. It shifts from visible light into infrared. Hubble was amazing, but it couldn't see far enough into the infrared to catch the first galaxies. JWST can. JWST has pushed the window back to just 100 or 200 million years after the Big Bang, expanding our view of the universe's infancy. But light isn't the only tool. We also have ears. I'm talking about gravitational waves. These are ripples in space-time caused by massive cosmic collisions. Detectors like LIGO, Virgo, and KAGRA don't see light, they feel gravity. As of late 2023, these detectors have confirmed about 300 black hole mergers. We are detecting the ghosts of collisions from billions of years ago. We are using nothing but the wobble of space itself to listen to the history of our universe. We have the eyes, JWST, and the ears, LIGO. Now let's look at the monsters lurking in the dark ages and the impossible galaxies breaking our models. Some of what we've found doesn't make sense. Galaxies that are far more mature than they should be for their age. This is forcing us to revise our models. We are learning that the early universe was far more active than we ever imagined. Every day, we're getting closer to the full origin story, from a soup of plasma to the complex home we have today. The archaeology of the Big Bang is just beginning. After the Big Bang, the universe was dark. We call it the cosmic dark ages. Then, the first stars ignited. Astronomers call these population 3 stars. Massive monsters hundreds of times larger than our sun, incredibly hot, living fast and dying young. We have never seen one directly. They are the holy grail of galactic archaeology, but we know they must have existed because of the mess they left behind. When they exploded, they seeded the universe with carbon, oxygen, and iron, the building blocks of Earth and you. By using spectroscopy, breaking light into its component colors, we can measure the ratio of elements in a star. If we find a star with almost no iron but a specific amount of carbon, we can infer that it formed from the ashes of a population 3 star. It's like finding a pottery shard and knowing exactly which kiln it came from. According to our standard theories, galaxy formation should be a slow process. You start with small clumps of gas, they merge, they get bigger, and over billions of years, you get a spiral galaxy like the Milky Way. But JWST found something impossible. Huge mature galaxies just 300 million years after the Big Bang. We're talking about candidates with stellar masses exceeding 100 billion solar masses. They are too big, too bright, and too mature for their age. They shouldn't be there. It's like walking into a nursery and finding a teenager with a full beard and a mortgage. It shouldn't be possible. This discovery challenges our models of how fast gas can turn into stars. It suggests that the early universe was much more efficient at building things than we ever imagined. So, how do you build a galaxy that fast? You need scaffolding. Dark matter provided the invisible gravity wells where gas could pool and collapse into stars. And then there's dust. It helps gas cool down to form stars. The early universe was a busy, violent, and incredibly efficient place. Speaking of violent, let's talk about black holes. The massive galaxies found by JWST were a surprise, but the black holes are a shock. We are finding monsters less than 500 million years after the Big Bang. Do you realize how crazy that is? In standard physics, black holes have a speed limit for how fast they can eat, the Eddington limit. But to get to a billion solar masses that quickly, they would have had to eat faster than the theoretical speed limit allows, continuously, for millions of years. So, how did they do it? Galactic archaeologists have a few suspects: direct collapse, where gas clouds skip star formation, and supermergers of existing black holes. We are seeing that galaxy mergers are the primary way the universe builds these giants. They don't just smash, they dance. They strip stars from each other. They trigger massive bursts of new star formation, and eventually, their central black holes find each other and merge. Our own Milky Way is destined to crash into Andromeda in 4 billion years. We are witnessing the prequel to our own cosmic fate. The early universe was a place of monsters and mergers, and JWST is just getting started. We have to keep looking up. There is one more crucial chapter in this history book: the Epoch of Reionization. For the first few hundred million years, the universe was filled with neutral hydrogen gas. It was like a thick fog that trapped ultraviolet light. The universe was opaque. But then, something happened. The first massive stars and quasars blasted out so much radiation that they burned off the fog. They ionized the hydrogen, making the universe transparent. For a long time, we weren't sure exactly what caused this. Was it the black holes? Was it the stars? Recent JWST data has given us the smoking gun. We have now directly observed ultraviolet light escaping from these ancient, tiny galaxies. It confirms that these early, hard-working galaxies were the ones that cleared the fog, ending the cosmic dark ages. We have learned more in the last 5 years than in the previous 50, but we're just getting started. In the mid-2020s, NASA will launch the Nancy Grace Roman Space Telescope, while JWST is like a sniper rifle, looking at tiny patches of sky in high detail. Roman is a wide-angle lens. It will survey massive areas of the sky to find thousands of these ancient galaxies. Then there's the Square Kilometre Array, SKA, being built in South Africa and Australia. It will look for the radio signatures of the very first neutral hydrogen, mapping the structure of the infant universe before stars even lit up. And we aren't doing this alone. We're using artificial intelligence. With telescopes like the Vera Rubin Observatory about to generate terabytes of data every single night, no human can look through it all. AI is helping us find the needles in the haystack, the rare anomalies that change physics. So why does this matter? Why do we spend billions of dollars to look at faint smudges of red light from 13 billion years ago? Because, in the end, this isn't just about distant light. It's our story. Galactic archaeology has taught us that we are not separate from the universe. The carbon in your cells, the oxygen in your lungs, the iron in your blood, all of it was forged in the nuclear furnaces of ancient stars that lived and died billions of years before Earth even existed. We are the result of galactic mergers, supernova explosions, and the gravitational collapse of dark matter. By studying these ancient fossils of light, we are contextualizing our own existence. As the saying goes, we are stardust, and thanks to galactic archaeology, we are finally figuring out exactly which stars we came from. If you want to keep exploring the universe with us, make sure you hit that subscribe button. We've got a lot more digging to do. Thanks for watching.